expelled because of him.
For farting?
Yeah. No, he was just like, it's not respectful to fart on purpose in class.
You know what? Wait, let me pause this.
Missing burnt hair over here.
Okay, we're in quadrant 2 and quadrant 3. One of these is extraneous. Does anyone remember where we are extraneous in this example? Which one is not a solution? Back when I think I just erased it. Oh, I didn't erase it. Look back here. When we were graphing these guys. When we were graphing, we said that the range had a restriction. We went from 0 to pi. Kian, what quadrants am I in if I go from 0 to pi? 1 and what else? You just went from 0 to 90. I want to get all the way to pi. No, pi is all the way over here at 1, maybe. So we're talking about the inverse of cosine. It has a restriction. Yeah. Be sure. So where's the restriction? Yeah. But 0 to pi is what quadrants? If I went from 0 to pi, how many quadrants did I go? Thank you, Beatrice. Yeah. Okay, I went from 0, I went to pi halves, then I go to pi. So I went from 1 to 2. So I'm in quadrant 1 and quadrant 2. So when I go back at my solution, where did it go? That's the question. Boom. Which one is outside of that range? The one that we just talked about. Quadrant 1 and quadrant 2. Okay, we have 2 solutions right now. Lucy, one of these 2 solutions is outside the range. Which one is outside the range? So when we went back here, range is from 0, thank you, from 0 to pi, right? We're looking at cosine? We went from 0 to pi. Okay. So 0 is over here. And I go all the way to pi. What 2 quadrants did I go to? I start at 0, and then I went to pi halves, and then pi.
180 degrees.
180. So this is quadrant what?
1.
And this is quadrant 2. So I can only be in quadrant 1 and quadrant 2.
Oh, I was looking.
So if I was looking at my solutions, which one is not in that range? 3. Yep. So this one, no go. So this is my answer. Cool. We're trying to find the answer. So if I evaluated inverse or cosine of negative radical 3 over 2, the answer is 150. This equals 150 degrees.
No, that's just my homework.
No, it's not. This is my lesson for this class right now.
You should have took photos.
Where did that go? Why? We're gonna do it. Cool. We did that last class. That was Thursday. This.
Oh yeah, easy peasy
Right? Yeah.
What graphing is? We're not graphing anymore?
No. We're done. Guys, you never have to graph again, except for the final.
Oh.
Yeah.
No, how much is the final on? Sweet.
All of chapter I will talk about the final later.
You want to leave on a good note. Trust me.
Imagine if you failed Beatrice and she couldn't graduate. Okay, let's not go to that.
What if you failed her and she has to redo her junior year?
What?
I just didn't hear what you said.
Exactly.
Okay. Find all angles in degrees whose sine is 0.95. That's the question.
0.955.
No, just 0.95. Find all the angles. Want me to start it for you?
What does 0.95 mean?
Yeah, what's 0.95?
Sine is 0.95.
Sine, that's what sine means?
Yep, sine is that.
Have you never
We're learning it now, but you do know that because we just did it. Yep. Whose? Wait, find all angles in degrees. Whose sine? Okay, so first things first. Find angle. Okay, we have 0.95 equals sine of theta. Okay. Okay, we did this last time. How, Desi, how in the world do I get theta all by itself? Yeah, how do I get rid of sine? I can't divide it. Okay, I have x squared, right? How do we get x all by itself? Yep, I do the undo operation, right? And I just get x. What's the undo operation of sine? Inverse of sine. Yes, inverse of sine. So I'm going to take the inverse of sine of both sides. So inverse of sine of 0.95 theta, because that's the angle. So sine, inverse of sine theta.
So, which one's sine and which one's not sine?
This is sine. This is inverse of sine.
So you gave us 0.2.
Yes.
If you gave us 13, what would that be?
13.
So when you say find the angles, it's always sine?
No, I said whom sine
Oh, I
is,
said,
yeah.
oh,
Yeah. I'll say cosine or something.
Oh, it's just.
I already told you a sine. Okay.
I was like,
Lucy, what happens on the right side of this equation?
It moves.
What moves?
Sine.
Did you listen to Declan?
Brother.
Don't listen to
I'm
Declan.
training her to stop listening.
Okay, remember over here. Wait. Okay,
It cancels out.
it cancels out.
Sine
Yep.
negative 1 and sine negative.
And what am I left with?
Just sine negative 1.95.
Okay, yes.
And
Wait. Yeah. What? Theta. Yep, theta on that side. No, I get it. Yes, but sometimes we're going to have things that affect theta. So then you're going to have to take an additional step. But we just need to know that the undo operation of sine is inverse of sine. So Declan, you had a calculator? No, you don't have a calculator. Okay, everyone get a calculator.
Hey, you can have this one. I have my own.
Oh, I didn't take attendance. Where's Yell? Is she ever going to come back?
I just don't think she's like. I think she's sick or something.
Oh, okay. Yell.
Oh my gosh, they should
Well-
have their drawn in mustache.
Oh my gosh.
Yeah.
Wait, go back.
Go back.
Wait, I want to see.
Wait.
Oh my god.
Funny, Declan.
Wait, go back. Dude, look at it. Wait, I think so.
Guys, this is forever going to be on YouTube now. Because this is still being recorded.
Oh.
It's gonna forever be wet. I'm crying.
On here.
Is Carson not in there? Yes.
Wait, is it just?
Look at the road.
Oh.
That's in that class.
Mine's.
Yeah, I'm pretty sure Carson does have it in his picture too.
Let's gonna do it. But my mom would kill.
Okay, shrink it down. So, sine, inverse. Inverse of sine of 0.95. Use your little calculators. What do we get?
Wait,
It's right there, thinking, right? So do second, and then hit sine.
Oh, I see it.
Yeah.
sine of 0.95.
0.95.
71.
0.805.
127.
Yeah. Did you? Okay.
72 because we're rounding.
We can round there. Did anyone get a very, very small decimal? Like 0.
That's theoretically it.
No.
One.
Wait, no, this is in radians, Jake.
Theoretically.
Oh.
It'd be this.
Now do this.
Yeah, I'm in degree also.
You're in degrees.
It would be that.
What did you get? Good job. Desi, what did you get?
Melted that.
I got
But
71.
Okay, so we got theta equals 71.8 something. Let's graph this guy. It's theta. Thank you. Okay. Look outside.
Oh my gosh.
Yeah. Jade, can you go get the door? Go. Okay, let's graph it. Look it. Okay, not graph it, but let's put it there. That's about 71.8 degrees, right? Okay, guess what? Your calculators are super, super stupid. There is 2 solutions to this. It only gives you 1.
Oh, negative something.
It only gives us one what?
It only gives you 1 answer. There's actually a lot more. But, yeah. So I said sine equals 0.95, right? It's positive. It's also positive in what other quadrant besides just
So then
one?
why do we turn it to negative theta?
So that we can get what theta is. We want to find the degrees.
So when you make it the inverse,
It gives us the degrees. Whenever we're trying to find degrees, we're going to have to use these.
well,
Yeah. Okay. Wait. They're all multiple answers. Sine is positive in the first quadrant. Where else is sine positive?
the second one.
Second quadrant as well. So it has symmetry over the y-axis. So this is also, if this theta is also the correct answer. This is pi minus theta. So this is 180 degrees minus whatever our degrees is, which is 71.8.
Wait, 180 minus what?
It's 180 minus whatever our degree that we got before.
So 71.8. 180 minus 71? Or no, 180 minus...
71.8, yeah. Which is what? 108.2. So those are two answers. So we're going to go over symmetry. That's only sine of symmetry. Sine is symmetric over what axis?
X.
Y. Did I say X before? It was Y. Y up there. Okay. Let's put our notes. Symmetry. Symmetry. Okay. We had sine. We take this function. If we're up here, it's also positive over here. That's the one we just did. So, you flip it. Symmetry over y-axis. And to get my other theta, this is theta. If I go a whole 180 degrees, it's kind of like bow ties and butterflies, right? We're drawing it like this. So that's what the other one is over there. I wouldn't sketch that. So this is all. This is pi minus theta. So use pi minus theta to get the other side where it's also positive. Now, cosine is positive in which two quadrants?
The first and fourth.
Yep, the first quadrant and the fourth quadrant as well. So that's symmetry over x-axis. I'm just flipping it right over the x-axis. So this is theta. Over here, this is negative theta. So you can put negative theta or 2 pi minus theta to get to other point.
So are those supposed to be like the same?
That's where, like, if I give you a value and tell me all the degrees that makes this statement true, there's going to be 2.
Let's say S, X, M, M.
Symmetry? S-Y.
Symmetry.
S-Y-M-M. Okay, last one. Yeah. More?
Wait, is the first one y-axis?
Yep, y-axis.
On the graph, are they supposed to be even or are they supposed to be...
This is supposed to be even with that one. Yeah. Okay, last function. We have tangent. Which two quadrants is tangent positive in? The unit circle. Like, we're just like, you know how on your test I was like, here's 680 degrees? So tell me where this angle is. So this is the terminal side of an angle. We always start here and we go here. So this is the terminal side of an angle. What makes them different? The unit circle. So this is all y values and this is all x values. So x is positive here and y is positive up there. Yeah. Okay. Tangent. Up here. Quadrant 1. Where is it also positive? Let's see, where's tangent positive? No. Jade. I said Lucy. I said Lucy. Jade, which quadrant?
3.
Let me answer this.
Okay,
It's
3. Down below. Right there. So this theta. So we have symmetry.
3.
Symmetry over origin this time. Symmetry over origin. How do we get this theta down here? We take theta, we add pi to it. Pi is how many degrees?
3.14. Sorry, I don't know why. It just came to my pause.
That's in radians though, which technically we should be doing these in radians, but we're just going to keep to degrees. What is it in degrees? 180 degrees. Because it's just flipping it. Like, I'm just like flipping it right over the origin. It should be, it's going to be the same theta. What, are you talking about tangent? Yeah, because this, I'm confused by your question. Yeah, because that's where they're symmetric. That's where the positive or negative. So like this one, the both sign. So all students take calculus. Sine is positive here. Cosine is positive right here. Tangent is positive here. Yeah. What's up, Wenzel? Go ahead. Okay, we good? Lovely. We got them stuck in our heads forever and ever and ever and ever. Guess what? You're taking pre-calc. You're gonna have to do this, but instead of just like a unit circle of 1, it's gonna be more and bigger.
Oh,
It's gonna be polar coordinates. Yeah.
I have to take statistics next year.
a unit square.
Probability. Okay, my college kind of skipped on the statistics and mostly just did probability, which is a lot of fun.
Oh, I didn't
Which
know.
we're not
IXL,
gonna.
stats and probabilities.
I'm
Yeah.
scared because
Just
well,
do IXL. Trust me. No, IXL gives you lessons on stats.
Okay, solving a trig equation. Probability is pretty easy. There's like not many equations. It's just a lot of word problems. That's the bit. Yeah. Solving a trig equation. This is going to be practice for factoring as well. Maybe later. Okay, number 1. We're going to take an equation. We have 6 sine of theta equals 3 sine of theta plus 2. I need to solve for theta. Yeah, I need to solve for theta. Declan. How do I, what? There's thetas. There's theta here and theta here. So Declan, we have like terms. What are our 2 like terms? Okay, so that's a very...
Like 3 and 2.
3 and 2?
Oh, 6.
No. Okay, those are just coefficients out front.
Ooh, what do you mean by like terms?
remember Yes.
I was in one, but it wasn't like that.
Theta
Wait. Problem.
Is it true
Problem.
you guys go to frat houses to party? You can't have alcohol in the girl one.
Guys, focus.
I'm so
Problem.
sorry. I'm so sorry.
Oh,
We'll
it's
save
funny.
it for brain break, right? No, we're doing the.
We're saving factoring for brain break to help.
Whoa.
Okay, looking at this problem, what are our like terms? What are our like terms?
Sine theta.
Yup, these are 2 like terms. How do I combine them? Yup, I heard subtract minus 3 sine theta. What do I...
3 sine theta.
Yup, what's on the other side?
2.
Okay, how to get rid of 3? Move it over.
Divide.
Wait.
2/3 equals sine theta.
Okay, how do I get theta all by itself?
Just the unit circle.
Slow down.
Oh, you
No.
inverse it.
Inverse it. Yes.
Oh, minus sine.
Minus sine.
No, you just it turns into
Or sine minus 1.
inverse sine.
Take the inverse of sine of both sides. So I have theta equals sine inverse of 2/3. Why did I do double there? That's so weird. That's so weird. Okay. Get a handy dandy calculators. What is sine? Inverse of sine of 2/3.
Easy then.
How do I do?
62.
Oh. 2.
41?
41.
41. Is that my only solution? What else do I have to do, Lucy?
It's 41.8.
Yeah. Good question, but I. Oh, you have to go like do the thing around quadrant.
Yeah, what line do I flip it over? What does it have symmetry? 41.8
Oh, 180.
degrees.
Quadrant 1 and 2.
Quadrant 1 and 2, so I'm flipping over the x-axis. So if I'm starting about right there for 41.8.
Wait.
Minus theta.
So I need to figure out if this is theta. You need to figure out what this is as well.
Wait, I'm confused about the graph part. How do you like do that?
Okay,
How
let's
do you
back it up.
find where your first line?
Okay. Wait. 41.8 degrees. If I'm here, how many degrees am I at? Okay, if I'm up here, how many degrees I'm at? 90. So like in the middle, it's like 41. All you gotta do is roughly what quadrant we're in. So I'm right here. I have symmetry over the x-axis, so I should be over here. If this is theta, how do I get this bigger theta? Yeah, what do we get? What's the other one? 130.2 degrees.
Whoa, that's not correct. 138.
What?
Right? Right? Yeah. Shit.
I don't think it should be this.
Because 30 plus 40 is 72. So 1.8.
138.2 degrees. Yep. Okay, those are our two solutions. Do we need to do another practice problem, or can we go up on the board? Yeah?
Board word.
We'll do one more together. Okay. Let's do 0.25 cosine of theta plus 1 equals 1.5 cosine of theta. What do I do first, Benj?
Wait, I need to write it.
Okay. Minus 0. You want to move this one? Okay. 0.25 cosine of theta, negative 0.25 cosine of theta. On this side of the equation, I'm left with just 1 equals 1.25 cosine of theta. What do I do next? Not yet. So close.
Oh, you minus 1.
I want to get cosine by itself first. Get this guy.
Oh, then divide by 1.
Yeah, 1.25 divided by 1.25. Because there's a 1 in our equation. Plus 1. So I'm just carrying this guy down. 0.8 equals cosine of theta. Now what do I do? Now take the inverse. So cosine. Take the inverse. Cosine inverse of this guy. Cosine inverse of 8.8. 0.8 equals theta. Declan, when you put that in calculator, what do you get? Inverse cosine of 0.8. Yeah.
36.86.
Yeah, I'm fine with that. Oh.
Oh, don't say that.
What was it? 36.8. What quadrant are we in for 36.8? Quadrant 1.
1 and 4 is the one.
Yep, I want 1 and 4. So if I'm up here,
Theta.
theta, I need to find the one down here. Yep, you can either do negative theta or 2 pi minus theta. I'm going to maybe not ask you for negative degrees. So you're going to have to give me the positive one. Or I might ask you for negative. So 36.8, negative 36.8. How do I make that positive? How much do I add to it? What? If I want to get a positive, if I want to make this positive, how do I get a positive number? Do 2 pi minus theta. Yep, 2 minus theta. 2 pi minus our original theta, which is what?
Negative theta.
Yeah, it's negative theta.
36.8.
Yep, but I don't want it to be a negative number. I want it to be a positive number.
Um,
So do 360 minus 36.8. What do we get?
13.2.
Wait, so then why do we do 2 pi theta?
323.3.
It's 2 pi minus theta. So this is 2 pi, which is the same as 360 degrees.
Oh.
323.
That. 2 pi is the same.
Mm-hmm. Boom. All three answers are good, but I might ask you for positive and negative.
Okay. Wait,
360 from our theta. Because 360 is the same as 2 pi, right? So, if I went from, if I'm down here, if I go a full circle, and I go minus whatever theta is, I'm still right here. And that's just the positive number. Positive version of it. Okay, you ready, Desi? I'm going to give you practice problems for up on the board.
Okay.
Yeah, okay. I should pick groups though, right? Okay. No, for up on the board. And Jade, Desi, Lucy,
Trinity.
Beatrice,
That's it.
Declan.
Then
Desi, how do you spell your short name?
with the sign.
It's
No, the other one doesn't say B.
this is
Oh, that's so true. How do you spell your short name?
With an
D-E-S-I, that's it? Oh, I've been doing it with a Y. Yeah. You know what? Wait, we have 1, 2, 3, 4, 5, 6, 7. We only have 7? Okay, 3 groups. Ready?
Yeah.
I mean, it's not bad.
How many times should I switch?
Wait, who's best? B.
B.
Where's Kid?
Oh yeah, we're skiing.
Kian.
Orlando
Okay, I like this. Yeah, let's keep this one. Oh, you voted this way.
You guys can do it. Yes or switch?
Yes.
Fine, one more time. Sorry.
Hey, let's move. Oh yeah, keep this one.
Okay, I'm gonna give you problems. Go up to your groups.
Whose group am I in? Oh wait, same.
No, B. B
No, it's not. This week, go back. They don't.
B and
Look, B and
Bench.
Peterson.
No, you're in group 1. Okay, guys, the faster we get done with this, the faster we can do some factoring problems. Well, no, it's practice for your test. Quiz.
Beautiful written.
Yes. I know, it's right. It's a cylinder. But yes.
Who are you talking to?
I'm sorry, I clown on you. Okay. It's up there. I can't tell you. You have to say it because I'm gonna say something.
Which one are we looking at? 3 tangent of theta.
3 tan theta minus 4 equals tan theta.
Wait, goes up
Maybe
X.
somebody should take the marker.
Yep. I'm changing it to x now.
Oh, not theta.
No, because it could be x, it could be theta.
I have good
You see sine, and it's really ugly. We can just change it to x equals sine of theta. Okay? So I'm changing all of these to x. Well, the 2 is just out front. It just becomes squared. So this is just sine squared. How do I factor this? Let's do review. This is review now. How do I factor? Where leading coefficient is not 1. Declan, how did you factor this?
Just factoring it normally.
Thank you. Yep.
Oh, so 2 had negative 1s, -2, and then you just negative.
On multiples.
I did 2. So we're gonna have 2x minus x minus 1.
Okay, so 2 times negative 1. Those are what we're splitting it up into. So if I take this down, this is review for your test. Quiz. 2x squared. Then we take this one. Plus 2x. Take this guy. Negative 1x. Negative 1. So that's coming from now up there.
Yeah.
2x.
Okay, looking at our first two terms, what is our greatest common factor of these two?
2.
Yes, put them together. 2 and x, put them together. 2x. I'm left with x plus 1. Over here, I'm just going to take out a negative. There, x plus 1. Perfect. I need to put these together. This one and this goes together. So I have 2x minus 1. I would definitely write this down because it's going to help for homework. Boom.
Homework.
More factors?
Like this problem is a problem in homework. So I have 2x. I'm just going to put this up top.
That
But then you can't retake tests and everything. So
you can't retake tests without your homework.
I have to have homework done to retake test.
Ooh.
Okay. We have x equals 1/2 and x equals negative 1 at this point. So now I have sine of theta. I'm putting it back in. Equals 1/2. I have sine of theta equals negative 1.
Did Holland play that?
Yes, that's always been the rule.
That's never been a rule.
Yes, it has.
I never do my homework.
Okay, inverse
Did I always take it?
of this side. I need to take the inverse of sine of both sides. So now I have sine equals theta equals inverse of sine of 1/2 and theta equals sine inverse of negative 1. Because I want theta all by itself, so I have to take the inverse of both sides. Yeah. So what is the sine inverse of 1/2 when we put it in a calculator?
30 degrees.
30 degrees. Is that our only answer for that one? No. It's also positive in what quadrant, Kian? Besides quadrant 1, where is sine also positive? So, yeah, in quadrant 1, where else is it positive? Sine.
Oh, sine.
2, right? So it's also in 150 degrees. Where is, if I put sine of negative 1, or you can look on unit circle, where is negative 90? Yes, so it's 270 degrees. Same thing. Yep. Those are my 3 answers for that problem.
So we don't have to like.
But actually, there's only 2 because 270 is in quadrant 3, which is in quadrant.
Well, I'm looking, okay. When we're evaluating, you're talking about the inverse, right? Yep. So when I'm giving you, if I give you just, say, sine inverse of negative 1, this is different from saying theta equals sine inverse of negative 1. The restriction only applies to this one. When we don't have an equal sign. This is an expression. We're evaluating an expression. This is an equation.
Yeah, but how does 270 work? Because sine isn't positive for 270.
No, it's not. It's negative 1, though.
But
So it's
not
negative.
the whole thing we just talked about.
It's where it has symmetry.
Oh,
Symmetry.
So there can be more than 2 answers.
I mean, you keep adding 360 over and over and over again. Negative 90 is also true. If you keep adding 360, you just keep getting answers and answers.
Hey, quiz.
We can talk about that more. Well, no, because it's, see, yes, negative, positive stuff. But remember, this is negative now. So instead of being up here, negatives are down here. So reflecting over the y-axis, we're just flipping it over this way now.
Then why do you ask us what it's positive if it doesn't matter?
This one? No, it does matter. This one is just special because it's down here. It's exactly on an axis.
Which means Opposite?
It's, well, no, I'm in the negative x direction, so it's negative. This number inside can either be negative or positive.
Yeah, but I'm asking you about 200 instead of degrees.
Yep, so where is sign? Negative 1 on my unit symbol. So at all my points, where is it negative 1? It's negative 1 down at 270 units. So 0, negative 1. Yeah. And it doesn't have symmetry because it's on the y-axis. Okay, we have 2 seconds. Not 2 seconds. We have 2 minutes. When I have a binomial, so I have a binomial a squared minus b squared. What is our equation? Pythagorean theorem. I love that. I wish we were in geometry right now, but we're not in geometry. For factoring.
Equals 0.
What do we call this? Yes, factored form, but this is called difference of squares. Whenever you see a binomial, this should be playing in your head. Okay?
Minus b and a plus b.
A squared minus b squared, so it has to have a difference. So it needs to be negative. It equals square root of both of them, negative and positive. Yep.
What was a squared plus b squared?
A, what?
A squared plus b squared.
You can't do anything with that. You can't do anything. That's the simplest form right there. B to the fourth? Okay, then you just have to keep doing it over and over again. That was for Desi for review. Desi, you good? Okay. Oh, don't know what that is.